Okay, this is lesson 3, and we are going to talk about translating lines. We've talked in the last lesson, we learned about translating along a vector, and we saw what happens to angles and points and lines there. And now we're going to just talk about lines a little bit more specifically. So just to open this up, I'd like you to look at exercise 1, use what you know about parallel lines, and try to draw a line passing through point P that's parallel to line L. And this down here is line L. So draw a point parallel to line L, and then try to draw a second line passing through P that's also parallel to line L that is distinct or different from the first one, and then see what you notice. Okay, so pause the video now and just go ahead and do that using a pencil and whatever you have. All right, so if I was going to do this, I'm gonna use a ruler, and I'm gonna draw a line parallel. And so what I'm trying to do is just make sure that this line is equidistant from the other line all the way around. So I'm just eyeballing it. I could measure and do that. Okay, so there's my line. And so I have a new line, and I'm saying it's parallel. But if I try to draw another line through P that's also parallel, I notice that it's just going to be the same line. So I can't do that. I can't draw another one. So there's only one line passing through point P that's parallel to this given line right here. And that's kind of a fundamental thing about geometry, and it's not something we're going to prove, but you will prove it in high school geometry. So we're just kind of preparing you for that. We're gonna look at some other things in a little more depth, but we're just going to accept this. So we're going to agree that there's only one line through that point P that will be parallel to the line that we started with. Okay, what I'd like you to do now is look at exercises 2, 3, and 4 and work on those, and then we'll be having a discussion about that. So go ahead and pause now and work on exercises 2, 3, and 4. All right, exercises 2, 3, and 4 are going to give us some specific things about, these are 3 different cases of translating lines along vectors. And so let's look at exercise 2 first. And for exercise 2, notice that the vector is part of the original line. And so when I translate that, and this is what yours should look like. Now I'm going to use red whenever I'm tracing my vector. You can use the same color, it doesn't matter, but for my demonstration, I'm going to use red for the vector, and then I'll use blue for whatever it is that I'm going to be translating. So let's make line L blue. So here's line L, and I'm going to translate it along AB. So I'm going to move like so, and let me get back in my field of view. So there's my line, and so what you should notice is that if the vector, and so I can trace it like this. So there's L, we'll call it L prime because it's the image, like that. So what happened was when the vector was part of the line, the line L and L prime, we're going to say they coincide, or they're the same line. Because even though I moved it over, they contain exactly the same set of points, which is what a line is. A line is just a set of points, and they're the exact same set of points, even though it's translated. Okay, so this is the case where the vector is actually my vector AB is part of L. So the vector is lying on L. Okay, so let's look at exercise 3 now. So in exercise 3 is a different case. So here we're going to translate line L, but vector AB is not on the line, but it is parallel to the line. Okay, so here's a situation where here's my vector AB. Go ahead and my line that I want to translate is parallel to the vector. Okay, so what's going to happen in this case? There's L. Okay, so we're going to go ahead and slide it. So remember, we translate, we take our beginning point and match it up to the ending point. Okay, and try to get it right here. So what we see here is that I'm going to trace my line here. So here I have like so, and there's L prime. So when the vector that I'm translating along is parallel, well, I'm going to use the symbol for parallel, is parallel to my line, then L and its image, L prime, also coincide. So we saw that it didn't need to be, the vector didn't actually need to be part of the line like in exercise 2, but if it's parallel, then the line and its image are going to coincide. Okay? So both of those are going to result in L prime being the exact same line as L. Okay, so let's look at exercise 4. Exercise 4 asks me to translate line L along vector AB. So here's my vector. Vector AB right here. And so in this case, AB isn't part of the line, and it also isn't parallel to the line. So here we go. There's L. And I'm going to translate this again. So I'm going to, again, it's a slide. I'm going to slide my overhead up so that my starting point becomes my ending point, matches up to the ending point. All right, so now we have the image of that line is right up here. So this is L prime, and I'll trace it right here. L prime. And so notice what happened here. So this vector is not part of the line. So vector AB is not part of the line, it's not part of L, or parallel to L. But L is parallel to L prime. Okay, so it resulted in my image, L prime, being parallel to the beginning, to my original line. And while translation requires a vector, a reflection requires a line of reflection. So we'll do an example before we get to this exercise. Okay, so here's an example of reflection. And in what I've drawn here, and you can draw a copy of this on your paper if you pause and want to catch up, or you can just watch. In this example, line L is going to be our line of reflection, and we're going to reflect points A and Q and P around line L. And so what I'm going to do in order to do this is I'm going to go ahead and copy them onto my transparency. And I'll make a copy of Q as well. Okay, and so in order to do a reflection, what we're going to do, it's also known as a flip. So we're just going to flip our paper over. Oh, forgot something very important here. I want to also draw the line of reflection because then I can match it back up. So here's my line of reflection. Okay, otherwise I don't know where to put it. Okay, so I'm going to flip it over. The line of reflection stays put, and everything else reflects around it. So notice P, which was on this side, ended up on the other side of the line of reflection. A was here and moved over to the right, and Q didn't move at all. Q was a point on the line of reflection, and it stayed in the same location. Okay, so what I want to do now is to use my pencil and mark where those points are reflected points, and point A is right here. And so if I look at my original picture, this would be the image of P. We're going to use that same terminology. There's the image of P, and then this would be the image of A. So A prime and P prime show the transformed points on that. And then we could also call this Q prime, but it hasn't changed. It's Q prime is the same point as Q. Okay, so you might be noticing some patterns going on here. And another way to refer to this, we could call this reflection L, because it's reflected about the line L. And you can also think of this as like line L is like a mirror, and so this is the mirror image. And if you notice, the letters actually end up backwards when we do this, because what we're getting is the mirror image of whatever we had on the other side. Okay. Okay, now you can go ahead and complete exercises 1 and 2 that you have in your notes, and then we'll do them together. So go ahead and pause now and work on that. Okay, now that you've had a chance to work on that, let me show you how I did it. Okay, so I've got my overhead sheet here. I'm going to trace my line of reflection first so I don't forget to do that. So there's my line of reflection L, and then let's trace our figures here. Okay, and I want to label the vertices of these because that's really going to be the important part of this translation, B, but I'll go ahead and draw the entire shape in and try to be as careful as you can. Okay, and then figure D over here. Notice this one has a curved line. It's a little different. There. Okay, so to do the translation, I'm going to flip it over and line up get my line of reflection and that point on there lined up. Okay, now this is going to be the tricky part. So, so here are my images, and I somehow have to try to transfer these onto my page. And so I'm going to mark the corners here first, and then draw the line, and then trace out the shape best I can. Okay, so it's not not an exact match. I'm going to turn this one around so I can work on it. I'm going to trace, let's get the points there, and then I can connect the dots with my ruler. That might be the most accurate way to do this. Okay, so this would be A prime, C prime, and of course B prime, just like in our first example, is the same as point B, and then this would be the reflection of D, of figure D. Okay. All right, so, and then in exercise 2, so these are our reflections. In exercise 2, it asks which figures were not moved to a new location on the plane under this transformation. Well, everything was moved under this transformation except for point B and then line L. The entire line L is in the same place. So those are the two things that were not moved. Right, exercise 1 tells us that we're going to rotate point P a certain number of degrees around center O. So P is labeled here for you, and we're told in this case to make D, our degrees of rotation, greater than 0. So that would mean we'd be going in a counterclockwise direction. And just a side note, the reason for that, which seems kind of backwards, the reason for that is because we're going to be doing these rotations on the coordinate plane. And if you remember the naming of the quadrants, this is 1, this is 2, 3, and 4. Quadrant 1, 2, 3, and 4, and that's the way the coordinate plane is laid out. So really rotating in a counterclockwise direction is going around the plane in the way that we want to go. Okay, so in the direction of the quadrants. So that's a reason for you there if you're trying to remember what's the positive direction and what's the negative direction. Okay, so I'm going to trace, just real quickly, I'll do this for you. You've already done it, of course. And so I get to choose my number of degrees, and I'm going to rotate counterclockwise because my degree of rotation is positive. I don't need to do any particular amount, so I could go further or closer. I'll go about right here. And then I'm going to trace my point is right here, and so this would be P prime, and I can draw the segment that joins it as well. Okay. All right, so that would be exercise 1. Let's look at exercise 2. Exercise 2 tells us to do the same thing, only this time D is less than 0. So we're going to do, sorry, that wasn't on there. So D is less than 0, so I'm trace my points, point P, point O, and I'm going to rotate clockwise this time. So I'm going to go way down here. So there's my rotation. Point O didn't move, point P did. So there's P prime. I'm going to connect it with the radius, and then we should have labeled this is D. There's my degree of rotation there. So there we go. So let's talk about 3 and 4. So which direction did the point P rotate when D was greater than 0? This would be counterclockwise. Positive rotation is counterclockwise. and a negative degree of rotation would be clockwise. This would be to the left. This would be to the right. Okay. I'll point out that in exercise 1, it specifies to use your transparency to rotate the plane 180 degrees. So what I want to do to do exercise 1 is I want to start by drawing that line. Drawing that line from the point through the origin and beyond, okay, like so. So I know that when I rotate this point, the point will end up on that line. So I'm going to rotate just that far. So I'm going to mark, I use my overhead on this one, mark my center of rotation and mark the point to -4. I'm going to rotate 180 degrees until that point matches up to the line. And when I get there, I know I've rotated 180 degrees. So the coordinates of my new point are the coordinates of this point, which would be -2, +4. So I can mark that right here. -2, +4. So my final statement here would be that rotation O of 2, -4 is the point -2, +4. Look at this one. This is a vertical line. I can use, let's use a different technique this time. Let's pick a point -4, -2. Draw my line through the origin. To find the image of that point. I can use my transparency to rotate. So there's different methods that you could use to do this, making use of what we know. There's my line, my point of rotation, and I know that this point is going to have to lie on this line somewhere. It has to be collinear. So I'm going to just rotate until that point matches up to the line. I'm getting there. And there it is right there. And then I could draw the line. I could have predicted the coordinates of this point because this point, and it's right here. So there's my point on the line. And I can see from my transparency that this is the line it goes through. So the coordinates of this point were -4, -2. So the reflected or the rotated point would be 4, 2, +4, +2. These two lines are parallel, the rotated line and the original line. Okay, that's 5 and 6.